Artificial intelligence has one massive problem, and it's not the one everybody argues about online. I'm Delia, a former Google engineer, and the real thing standing between us and AGI is not some genius idea that nobody's had yet. It's something way more boring and honestly kind of scarier than that. The biggest bottleneck in AI right now is not intelligence at all, it's electricity. And once you see why, you're never gonna look at this industry the same way again. Quick intro if you're new here, I spent years as a software engineer working from everything from startups to big tech, and now I post here where I break down what's actually happening in AI without the hype and without the constant doom. So I just try to tell you what's real. I am a little bit of an AI optimist, but today I'm going to talk to you about something that I genuinely think is the single most misunderstood thing in the entire field, because the headlines all tell you the same story. They say that AI is about to go super intelligent any day now. We're going to reach ASI and AGI, and they say the models keep getting smarter every few months. To be fair, that is true. They are, but almost nobody connects the dots on what it actually takes to keep that progress going. And when you finally do connect those dots, you realize we're heading straight towards a wall. Like, not a philosophical wall, not a wall made of hard math, but like a physical wall made out of computer chips and concrete and power lines and cooling water. So that's how the conversation has flipped. So by 2026, AI isn't just a software story anymore, it's a hardware and energy story. So let me actually walk you through it step by step, because this is one of those things that sounds insane until somebody just shows you the pieces, and it's really not that hard to understand. So let me start with the questions that everybody asks. What are we actually missing to build AGI? Are we getting AGI by 2026, AGI by 2029? Just so we're all on the same page, AGI stands for Artificial General Intelligence, and it basically means a system that can do a wide range of tasks that humans can do across a bunch of different domains. So it has the breadth. Now the popular answer is that we're missing some clever new design, a new architecture, a new approach, a new spark. And people love this answer because honestly, it's quite romantic. It means one brilliant person in a garage could change the world overnight. And look, I don't want to dismiss that, because new ideas really genuinely do matter. Like the transformer, which is the core invention behind basically every modern LLM, every large language model, was a genuine breakthrough back in 2017 when Google did it. Okay, I'm actually reading Attention Is All You Need right now, and a lot of those ideas are outdated, but ideas do matter a lot. But here's the thing I really want you to sit with for a second, because for the last several years, AI hasn't gotten better because of clever new ideas. It's gotten better because we threw more of everything at the same idea we already had. We threw more money, more data to learn from, more chips to run on, more electricity to power those chips, and that's generally most of the secret. We just took something that worked a little bit and made it absolutely enormous, and it turned out bigger kept working. So bigger is better in this world. And the people inside this field have a name for this. They call it scaling. And scaling has quietly been the real engine behind almost all the progress we've seen. There are exceptions to this, like DeepSeek did some real optimizations, but mostly scaling is the engine. And the question isn't really what idea are we missing? The question is, how much bigger can we actually go before something physically stops us? And that's exactly where this gets wild, because we are facing physical limitations. The chip problem. So let me talk about the chips, because this is where the whole story really lives. As you probably know, when you type a message to an AI and it answers you back, somewhere in a building far, far away that you will never get to see, thousands of highly specialized chips are doing an enormous amount of math just to produce your little ChatGPT answer of what the weather is. And these aren't the chips inside your laptop or your phone. They're a special kind of chips. They're usually GPUs. We're optimizing for others, but for now, let's say it's GPUs, and that's why most of these chips are owned by NVIDIA. This is the biggest reason why it's one of the most valuable companies on the planet, because as of right now, it's worth around $5 trillion, which is generally hard to even picture. But their whole thing is GPUs, right? Because they came from gaming. So its hardware basically became the oil of this new era, and suddenly everybody on Earth needed it at the same time. Now, here's what most people don't realize about these chips. So training one of these big models, the part where the model actually learns everything it knows, can take tens of thousands of GPUs running together, nonstop, for months. Not minutes, not days, but months, and even longer. And each chip costs a genuinely staggering amount of money. So when a company tells you they spent hundreds of millions of dollars to train one model, understand that's not marketing fluff, like that's literal hardware and electricity bills that they had to pay just to get that model to exist. And it's expensive, which is why a lot of companies do dilution, and like China's stealing from the US is stealing from China. But basically this creates a huge bottleneck that has nothing to do with how smart anyone is. You could have the best researchers in the world and the best idea in the world, and none of it matters if you can't get your hands on enough chips. And here's the part that genuinely shocked me when I understood how narrow this is, but around 90% of the world's most advanced chips are manufactured by exactly one company, TSMC, on one island in Taiwan. That one company makes basically every leading edge chip NVIDIA designs, but it goes a layer deeper, and this is the part that should really make you sit up. To make those chips, TSMC needs an incredibly specific machine, and there's only one company on the entire planet that builds it. It's a Dutch company called ASML, and they have a complete monopoly on the machines that print the most advanced chips on Earth. Each one costs around $250 million, okay? They take years to build, and there's no substitute for them anywhere. None. And honestly, when you hear these machines work, it sounds like science fiction. So to make the chips, the machine blasts microscopic droplets of tin tens of thousands of times every second with some of the most powerful lasers ever built. Then it bounces that light off mirrors so perfectly smooth that they're smoother than the mirrors we put in space telescopes. And then the finished machines get assembled in the Netherlands, which I'm going to next week. And they get shipped to Taiwan in pieces. So really picture this, a huge part of the future of AI depends on one Dutch machine building chips at one cluster of Taiwanese factories held together by a supply chain so concentrated it's honestly held together with tape and luck. One earthquake or one conflict in exactly the wrong place and the whole thing wobbles and falls apart. That's kind of whack. That shook me. That shook me to the core. But okay, let's pretend for a second that you somehow solve the chip problem completely. Let's pretend you can get all of them that you could ever want. Well, you still run headfirst into one problem that I mentioned at the very start. It's power. Plain, ordinary electricity. You know, Tesla was trying to solve this. But these data centers, which are basically giant warehouses packed full of chips, they drink electricity like almost nothing humanity has built before. And I don't want you to just take my word for it. So here's the actual direction of travel. So in the US alone, government researchers project data center electricity demand could roughly double or even triple by 2028. To put that in human terms, that's an enormous amount of new load piling onto a grid that already takes years to expand. And here's the part that shows you how different this is. So a single AI request can use a lot more electricity than a traditional web search, and for a long, complex answer, dramatically more. Of course, depending on the model and how the system's deployed. That's exactly why just a handful of these AI buildings can put real stress on a local power system in a way that ordinary office servers never could. And the grid operators are genuinely sounding the alarm. Like the largest grid operator in the US has been warning about capacity shortfalls within the next few years if new generation and transmission don't come online fast enough. All the grid providers are like freaking out. And this is the exact moment where this stops being a tech story and starts being a real world physical story that touches everyone. Because you can't just summon a gigawatt of power out of thin air whenever you feel like it. You need actual power plants, you need transmission lines, you need transformers, and I mean the electrical kind, not the robots, and there's a global shortage of those too. So you need cooling systems, which often means a lot of water. I'm sure you've all seen the memes. And sometimes truly enormous amounts of it. And every single one of those things takes years to build, and all of it runs straight into the same physical grid that your house and my house, I mean, I don't have a house, but you get the point, are already plugged into. So we've hit this genuinely surreal moment where some of the biggest AI companies on Earth aren't even thinking like software companies anymore. They're starting to think like energy companies. And I'm not being metaphorical here, I mean like literally. Microsoft signed a 20-year deal to restart a reactor at 3 Mile Island just to power its AI. And yeah, that is the same site as America's most famous nuclear accident back in 1979, though to be clear, not the reactor that actually melted down. Google has agreements lined up for next generation nuclear from small modular reactors. Amazon's been pouring billions into nuclear capacity right next to its data centers. And when I was still at Google, the idea that a software team would be sitting around worrying about nuclear reactors would have sounded completely insane to me. And now it's basically just a normal Tuesday in the industry. Like, this is actually the biggest problem in AI right now. And we do live in a physical world. So let me come all the way back around to the real question. So what are we actually missing to reach AGI? I want to give you the honest version, the one that I'd give a friend over coffee, not the hype version, and definitely not the doom version. I'm definitely an AI optimist over here, but let's be realistic. So the first thing we're missing is simply enough compute, and by compute I mean the chips and the power taken together as one big problem. So that's the wall I just spent the last several minutes talking about, ranting about. So even if we somehow had every idea perfectly figured out, we don't have nearly enough of the physical stuff to keep scaling the way the trend wants to. Like, this is the scaling, but that's a very real, very hard limit, and people underestimate it more than almost anything else. Important part, though, is that there's a second thing we're missing, and this one isn't physical at all. We might actually be running low on the easy fuel, the easy training data. So these models learned almost everything they know by reading huge amount of text, mainly from the internet. That's genuinely how they got this smart. But the catch is, there's only one internet. Like, researchers who study this estimate that the high quality human written text online adds up to somewhere around a few 100 trillion words. And the best guesses put us on track to chew through that easy usable part of it sometime between now and the early 2030s. So the cheap, abundant fuel that powered the last few years of progress is starting to run dry. We're not gonna like train them on AI slop, right? Which means just making everything bigger and bigger might not keep working forever the way that it has been. And then there's the third thing that we're missing, and this is honestly the most uncomfortable one for people in the field to admit. We don't fully understand why these models work as well as they do. Like, it's still a black box to a lot of people. So we know how to build them, we know how to make them bigger, but the deep underlying reason why they're this capable and why everything works is still not fully understood. Like, we get the basic math, but even the brilliant people building them don't fully understand how it works. And there are still things humans do incredibly easily, like reasoning through a brand new problem we've never seen or learning a new concept from a single example, that these systems still struggle with. This isn't just my take. Like, a major survey of AI researchers found that 3 out of 4 of them think that simply scaling up to today's approach is unlikely to get us all the way to real artificial general intelligence. So it's entirely possible that no amount of chips and no amount of power ever gets us there, and that we really do still need a genuinely new idea, a new way to do it, not through transformers, but through something else. And to be totally fair, not everyone agrees, and I want you to hear both sides. So there are very seriously smart people running some of the biggest labs in the world who think AGI could arrive in just the next couple of years if scaling keeps working and reasoning systems keep improving. And then there are others who think we're close, but we still need 1 or 2 more real breakthroughs in planning and memory and reliable reasoning before we get there. So to be honest, the answer is that it's genuinely all of these things at the same time. We do need a lot more compute. We're starting to run short on the easiest data, and we might still be missing a real conceptual piece of the puzzle. So anybody who confidently tells you it's just like one single thing holding us back is almost certainly oversimplifying or trying to sell you something. And there's this great triangle that explains the main problems and what's holding us back from AI that I will discuss in a later video, because there's a lot. There's a lot to talk about here, guys. But anyway, why do we even care about this? Why do we care? Why do we care about AGI? Now, you might be sitting here thinking, okay, Delia, this is all very interesting, but I'm not the one building a data center, so why does this actually matter to me? And here's why. Because this physical bottleneck quietly shapes almost everything that you personally experience as a user of these tools. It's the reason that the best models cost money while the free ones are always a little bit more limited. It's the reason why companies cap how many messages you can send in a day. It's the reason why I literally just hit my rate limit on Claude 2 minutes ago and I decided to film this video. And here's the one that's gonna hit you the most directly. If you happen to live near one of these giant data centers that are getting built, so you could be spending more money to just be in the grid because of AI. And in a lot of those places, people are already fighting about who's gonna pay for all of that new infrastructure, and a lot of the companies are paying for it, so it's fine. But is it really fine? Because that brings me to the single biggest takeaway that I want you to walk away with, that the barrier to entry in this field used to be raw talent and clever ideas, but now the real barrier has quietly become something completely different, and it's become whether or not you can afford to build and secure enough power. So that's why all of these big AI companies are getting a lot of funding. The industry even has a name for it now. They call it the power moat, because the cost of reliable energy, grid access, cooling, land, and chips is so enormous that only a tiny handful of companies with the absolute deepest pockets can fully compete at that frontier. So to give you a sense of the scale, the biggest tech companies are on track to spend north of $500 billion in 1 year, in a single year, just building this stuff out, with some estimates for 2026 pushing toward like 700 billion. So that kind of money completely changes who gets to shape this incredibly powerful technology. And to me, that's a far bigger deal than whatever trick the model can or can't do this particular month. So here is where I personally land on all of this. Whenever somebody asks me if AGI is really coming, I mean, I do think it's coming. I don't think the honest answer though is a simple yes or no. I think the real answer is that it depends on whether we can pour enough concrete and run enough power lines fast enough, and whether those easy gains keep coming, and whether somebody out there finally finds that one missing idea, and whether or not the governments are going to allow it. So the intelligence part might be honestly the easy part, and that truly hard part is everything standing underneath, which nobody really bothers to put in the headline: the chips and the power and the water, and a global supply chain that's way more concentrated than most people realize. And I actually think there's something kind of beautiful about that in a weird way, because we spent decades imagining the real limit on AI would be some deep philosophical mystery about the nature of the mind. And it turns out that the limit, at least right now, the limit might just come down to whether we can manage to keep the lights on. And that's kind of really hilarious. So if this changed how you think about all the AGI hype even a little bit, do me a quick favor, hit that subscribe, because I make videos like this every week and I genuinely read the comments because there's not a lot of them. So put some down below. Tell me what you actually think. Do we hit the physical wall first, or do we find the missing idea first? When do you think AGI will happen? I really want to know where you land. Let's see like what the genuine consensus is. I do think we're gonna hit AGI in the 2030s personally. Like, I think all of these problems are pretty solvable. They're just all not what people are talking about. So anyway, I hope that you enjoyed this, and I will see you in the next one. Bye.